Okay, in this video I'm going to give an introduction to motion in two dimensions, right? Okay, let's begin. Let us say that this is a road, and let us say there's a vehicle moving on this road, right? Let us say this is a vehicle, right? I'll show it with the help of a block, right, rather than actually drawing the vehicle to save time, right? And even otherwise my drawing is not very good. So let us say this is a vehicle, and let us say it is stationary. Let us say initial velocity is 0, and after time t equal to 2 seconds, let us say it reaches over here, and its final velocity is, let us say, 6 meters per second, right? If I'm asked to calculate the acceleration of this, I'll be easily able to do that. 6 minus 0 upon 2, v minus u upon t, 3 meter per second square. That is the acceleration of this vehicle. The initial velocity was in this direction, the acceleration is in this direction, and therefore the final velocity is in this direction. The displacement is also in this direction. That is why this type of motion is known as motion in one dimension. This is an example of motion in one dimension. Reason: initial velocity and acceleration are in the same direction. So when initial velocity and acceleration are in the same direction, we call it motion in one dimension. Now let us take one more example. Let us say this is again ground, and let us say this is supposed to be a tower, right? And let us say we drop a ball from this particular height. Let us say the height is h. A ball is dropped from this particular height. Initial velocity is 0. We know acceleration in this direction will be 9.8 meter per second square. Right? Direction of initial velocity downward, acceleration also downward. So this is also known as motion in one dimension, right? I have a question now. If I have the same tower, let me draw it again over here. Let us say this is the same tower. Let's not worry about the height. Right, let us say this, from the same tower I throw a ball in the horizontal direction. So I'm throwing this ball in the horizontal direction. In such case, what would happen? Now the initial velocity, this is u, and let us say this is 2 meters per second, is in the horizontal direction. The most interesting thing that happens is immediately after this ball leaves my hand, this ball is under the influence of only one force, and that is the force of gravity, and that will apply a force in the downward direction. That means the acceleration is in the downward direction. Let me repeat. The moment it leaves my hand, the only force which is acting on this ball is force of gravity. And we know force is mass into acceleration. This ball will certainly have some mass. There is a force of gravity acting on it, so it will have some acceleration. And that acceleration will be in the direction of the force. Right? Therefore, the only acceleration that is happening or is acting on this particular ball is in the downward direction. And you can see this difference over here. The direction of the initial velocity is in the horizontal direction, whereas acceleration is in the downward direction. And this type of motion, in which the direction of the initial velocity and the direction of acceleration are different, is known as motion in two dimensions, or plane motion. Right. Reason very simple: because the object is moving in two dimensions. Because of this acceleration in the downward direction, the path that this ball will take will be something like this, right? Something like this. Right? So the ball is moving in the horizontal direction as well as the vertical direction, right? Hence motion in two dimensions. And plane motion, because if the ball is moving in a plane, if I look at this as plane of the paper, then it is moving in this plane, whereas here it was moving in only one line, right? Therefore this is an example of motion in two dimensions, or plane motion, and we are interested in understanding motion in two dimensions. Let us take one more example, right? Let us say this is a playground, right, and a cricket match is on, right? And let us say the batsman and the wicket keeper are somewhere over here, and this is the fielder on the boundary line, and he throws a ball, right? He wants to throw it to the wicket keeper, right? And it falls short of the wicket keeper somewhere over here. What is the path it will take? It will take a path something like this, right? It will take a path something like this, right? Maybe something like this, right? Supposing it falls over here, right? The curve has not come out very well, but I'm sure that you are able to see that this path the path that it will take will be this path, right? So what happens over here is again something very similar. When it starts, it has initial velocity u. So, but the initial velocity is in this particular direction, the direction which is tangent to the initial point of this curve. So this is the direction of initial velocity.